Hello, future engineers. This video discusses about the solutions to problems on counter diagonals, the construction of influence lines, and one problem on space truss. So if you're still new to my YouTube channel, don't forget to subscribe and press the notification bell so that you will be updated on my future videos, which will be beneficial to your studies. So I hope that you can follow the solutions, and please be patient in the explanation so that's is the thing that you should do in order for you to understand the concepts. So for problem 1, for the plain truss shown with counter diagonals made of flexible cables, determine the axial forces in counters BF and CG when letter A, P is 40 kilonewtons and Q is 0. Letter B, P is 40 kilonewtons and Q is 80 kilonewtons. And letter C, P is 0 and Q is 80 kilonewtons. So this is the given figure, and let's denote the upward reaction at A as AY, and the horizontal reaction of obviously is 0, and at D it's R sub D. So first, summation moment about D equals 0. Let's generalize the solution. Let's involve P and Q. So summation moment about D equals 0 clockwise is positive. So we have AY times 15 minus P times 10 minus Q times 5 equals 0. Solving for AY is 2/3 of P plus Q over 3. So let's assume that the shear in this panel containing members BF and CG, the counter diagonals, as downward. So let's now determine V in general in terms of P and Q. So AY minus P minus the shear in this panel equals 0, summation versus Y, of course. So the shear in the panel is AY minus P, where AY is 2/3 of P plus Q over 3, then minus P equals minus V equals 0. So the shear is negative P over 3 plus Q over 3. So let's substitute for case A. P is 40 and Q is 0. So negative 40 over 3 plus 0 over 3. So shear is negative 40 over 3. Because the shear is negative 40 over 3 and we anticipated that the shear is downward, it means that the shear is upward. So if the shear is upward, BF should be directed up to the right, so same as the direction of the shear, and CG should be up, also up to the left. Since CG is in compression by the nature of its direction, then we conclude that CG, because this is in compression, and remember these counter diagonals are made of cables, flexible cables, they cannot resist compression. So CG therefore is 0 and BF is in tension. So FCG is 0. So we equate the vertical component of BF to the shear in this panel, which is 40 over 3 upward. So 40 over 3 equals the vertical component of BF is FBF times 4 divided by square root of 5 square plus 4 square, or square root of 41. So FBF times 4 over square root of 41. Solving for FBF is 21.34 kilonewtons tension. So let's proceed to letter B, where shear is negative 40 over 3 plus Q 80 over 3. So V is 40 over 3. This time the shear is, the direction of the shear in this panel is correct, that it is downward. Therefore, BF should be in compression, opposite to this direction. BF should be compression, it is down also to the left, and CG should be down to the right. So this time BF is in compression and CG is in tension. So because these again are made of ropes or cables, FBF is 0 and FCG is in tension. So FBF is 0 Again, the y component of CG, which is FCG times 4 over square root of 41, is equated to 40 over 3. Then FCG is equal to 21.34 kilonewtons tension. And let's proceed to letter C, where P is 0 and Q is 80. So shear is negative 0 over 3 plus 80 over 3. So shear is 80 over 3 kilonewtons. And again, the shear is correct, direction downward. Therefore, still FBF is in compression, so it is 0, and FCG is in tension. So FBF is 0, and FCG, the vertical component of FCG, which is FCG times 4 over square root of 41, is equated to 80 over 3. Solving for FCG, FCG is 42.69 kilonewtons tension. So that's it for this problem here. Okay, for problem 2, we have influence lines construction. By the basic method of constructing influence lines, construct influence line for reaction at A, shear at C, reaction at D, and moment at E. Also compute the maximum values of the above functions due to concentrated load of 18 kilonewtons. These are live loads, and live uniform load of 6 kilonewton per meter. So this is the figure. So first, let's draw the free body diagram of each part. So this is for portion AC because we have an interior hinge at C. So let's call RA as upward RA, and shear at C. Of course, AX is 0 and shears at C. For 0 to 12, the unit load will be somewhere between A and C. So we will call the distance of that unit load from the left as X, and therefore its distance from the right is 12 minus X. When the unit load is now on the portion C to G, so this is the free body diagram, and the unit load may be placed anywhere between C and G, and the distance from the left is X, and therefore its distance from F would be 24 minus X. That's it. And let's call this R sub D and R sub F. So this is the construction of the influence line. So summation moment about C equals 0, clockwise as positive. So for this free body diagram here, so we have RA times 12 minus 1 times quantity 12 minus X equals 0. So R sub A is 1 over 12 times quantity 12 minus X. This is for 0 less than equal to X less than equal to 12 meters. Then when the unit load is beyond 12 meters, so it's now here. So if we sum up, this is the free body diagram. The unit load is now on the portion CG. If we sum up moment about C, then RA times 12 equals nothing. So therefore RA is 0 when X is greater than equal to 12 for that case. So let's now plot RA when X is 0, 1 times 12 minus 0, so 12 over 12, so 1. When X is 0, it is 1. When X is 6, 12 minus 6 is 6 over 12 is 0.5. When X is 12, 12 minus 12, so 0. So this is it. Then after that, for X greater than equal to 12, it is 0. So that's the influence line for reaction at A. So for the influence line for shear at C, so for 0 to 12 here, summation moment about A equals 0, counterclockwise as positive. So we have V sub C times 12 minus 1 times X equals 0. So V sub C is X, 1 times X over 12. This is for 0 to 12. That's the range of values of X. So when X is greater than 12, the free body looks like this. So if we sum up moment about A, then V sub C times 12 plus nothing equals 0. So that means V sub C is 0 for X greater than 12. meters. So let's now plot. So when x is 0, shear at C is 0. When x is 6, 6 over 12 is 0.5. Then when x is 12, 12 over 12 is 1. So 0, 0.5, then 1. Then beyond that, for x greater than 12, the shear at C becomes 0. So that's the influence line for shear at C. Now for the maximum values, due to this live concentrated load and uniform live load, then by principle, we place the concentrated load over a point where the ordinate is maximum for reaction at A. So which is 1. So we have 18 times 1 times W times the area where the area is maximum. So plus 6, and the area is 1/2 or 0.5 of 12 times 1. So the maximum reaction at A is 54 kilonewtons. Then for the maximum reaction at C, it is the 18 kilonewton load should be placed over C, just to the left, or over C. Then it is equal to 18 times 1.0, then plus 6 kilonewtons, then the area under this maximum ordinate area of this triangle is, so 6 times quantity 0.5 of 12 times 1.0. So maximum shear at C is 54 kilonewtons. Then for reaction at D, next. So we have V sub C here from 0 to 12, then 12 to 30 meters, this is the free body diagram, and the unit load will now be here. So for 0 to 12 first, there is V sub C, and there is V sub C, this is the free body diagram. So if we sum up moment about F equals 0, so we have R sub D clockwise positive, R sub D times 6, then minus V sub C times 12 equals 0. So that means R sub D is 2 times V sub C. This is from 0 to 12. That's the formula for R sub D. Then from greater than 12 up to 30, this is now the free body diagram. And for that case, we learned that V sub C is 0. Got V sub C here, 0. So we equate this to 0. The forces are only RD, RF, and the unit load. So summation moment about F equals 0. So we have R sub D times 6 minus 1 times 24 minus X equals 0. So R sub D is 1 over 6 times 24 minus X for X greater than 12. Greater equal to 12. Now let's now plot. So we have two formulas to plot. First is RD is 2 times V sub C. This is V sub C. So we have influence line for R sub D. So 2 times V sub C, 2 times 0 is 0 here. 2 times V sub C, so this is 0.5. So 2 times 0.5, it is 1 here for RD. And when X is 12, 2 times 1 is 2. So 0, 1, and then 2. Then for X greater than 12, this is now the formula. So we set X is 12. 24 minus 12 divided by 6 is 2. That's why we have continuity, 2. Then when X is 18 at D, 24 minus 18 is 6 divided by 6. So it's 1 here. Then when X is 21 at E, so 24 minus 21 over 6 is 0.5. So 2, 1, then 0.5 at E. Then when X is 24, it is 0. Then when X is 30, 24 minus 30 divided by 6 is negative 1. So again 2, then 1, then 0.5, 0, then negative 1 here. That's it, the influence line for RD. And for the maximum RD, the positive area is greater than the negative area. So maximum RD is 18 times 2. We play the unit load position, the load position, the live load position, concentrated load would be here. So 18 times 2 plus 6 times the area of this triangle, which is 6 times the area is 1/2 or 0.5 of 24 times 2. 0.5 1 half of 24 times 2. So RD max is equal to 180 kilonewtons. Then for ME, so let's draw the free body diagram for ME. Then from 0 to 12, there is value of V sub C. So V sub C is there. Then the unit load is not yet there. Then this is shear at E, then moment at E. So summation moment about E equals 0, so counterclockwise positive. So ME plus V sub C times 9 minus RD times 3 equals 0. So ME is 3RD minus 9V sub C. So this is the equation. So from 0 less than equal to x less than equal to 12 meters. Then for greater than 12 up to 21, the unit load will be here and V sub C is 0. So the unit load will be positioned there. Its distance from A is x. So therefore its distance from E, because E is 21 meters from the left, so 21 minus x. So the equation would become summation moment about E, ME plus 1 times 21 minus x minus RD times 3 equals 0. So ME would be 3RD minus 1 times 21 minus x. For this is applicable for 12 less than equal to x less than equal to 21 meters. Then finally, when x is greater than 21, the unit load will now be on the other segment. So there is no unit load here. So we remove this contribution of unit load. Then ME is 3 times RD. That is for x greater than equal to 21. So if we plot first 3 times RD, this is the influence line for RD. 3 times 0 is 0, minus times 9 times V sub C, and V sub C is also 0. Remember, this is V sub C. So when x is 0, ME is 0. When x is 6, RD is 1. So 3 times 1 minus 9 times V sub C. V sub C is 0.5. This is V sub C. So 3 times 1 minus 9 times 0.5 is negative 1.5. Negative 1.5 here. When x is 12, RD is 2. 3 times 2 is 6. Minus 9 times V sub C. V sub C is 1. So 6 minus 9 times 1 is negative 3. So 0, negative 1.5, negative 3 here. When x is between 12 and 21, so this is the formula. So 3 times, when x is 12, 3 times RD, 3 times 2 is 6, minus 1 times 21 minus 12, which is minus 9. So 6 minus 9 is still negative 3. We have continuity. Then when x is 18, RD is 1. So 3 times 1 minus 1 times 21 minus 18. So 3 minus 3, it's 0 here at 18. When x is 21, then this is 1 minus 1 times 21 minus 21, 0. And RD is, when x is 21, is 0.5. So 3 times 0.5 is 1.5. So negative 3, 0, 1.5. Then when x is greater than 21, this is now the formula, 3 times RD. So when x is 21, 3 times 0.5 is 1.5. We have continuity. When x is 24, RD is 0, so 0. When x is 20, x is 30, RD is negative 1, so 3 times negative 1 is negative 3. So it's negative 3 here. So this is the influence line for R sub D. So we observe that the negative area is greater than the positive area. So the maximum moment at E is negative, and it is equal to, so we place the concentrated live load either here or at the NG. So it is 18 times negative 3, then plus uniform load. There are two areas. So 18 times negative 3 plus 6 times quantity 0.5 of 18 times negative 3 plus 0.5 of 6 times negative 3, the area here. This is the area here. So moment maximum at E is negative 270 kilonewton meter. So that's it for this second problem. Okay, for problem 3, the truss shown consists of 9 members and is supported by a ball and socket at B, a short link at C, and 2 short links at D. Determine the force in each member for P is 0 and Q is negative 900. So this is directed in the opposite Z direction. Can you find the zero force member? Which member is it? So this is the figure, and for Q is equal to 900. So let's now assign the reaction components. So we have for B, there are 3 reaction components, Bx, By, and Bz. So these are the assumed direction for the reaction components at B. At D is, that's only one, 2 rather, we have Dy and Dz. And at C, there's only one because there's only one short link. So I assume it is downward. Then for the forces, so by the way, before we proceed, we have to solve distances or lengths of the members, especially these inclined members. Distance AB, so x component of distance is 0.6. This is x. This is y vertical, then z, this one. So 0.6, then along y is 3, then along z is 0.75. So square root of 0.6 square plus 3 square plus 0.75 square. Distance AB is 3.15 meters. Next, distance AC. Distance AC is along x is 1.2. So square root of 1.2 square. Along y 3. So square root of 1.2 square plus 3 square. Then plus along z 0.75 square. So this is equal to 3.317. Try to check it. Square root of 1.2 square plus 3 square plus 0.75 square. So 3.317. Then distance of AD is along x 1.2, square root of 1.2 square plus 3 square, then plus 2.25 square. So that's why distance AD is 3.937 meters. And there's no need to compute distance AE because the zero force member based on the given figure is distance is force of member AE. Force of member AE is 0 because that's the only force which is perpendicular to the planes of the 3 members BE, CE, and DE. So if you sum up forces Y equals 0, then force of E is 0. So the answer to the, can you find a zero force member? So based on the given figure, it is member AE. So force of member AE is 0. Then distance CE is square root of along x is 1.8, so 1.8 square plus along y 0, then along z 3. So square root of 1.8 square plus 3 square is 3.499 meters. So these are the forces. FAE is 0. The reason is it's the only force that has unique line of action perpendicular to the planes of these 3. Then we have FAB. We assume always that the force in a member is tension. So F, CD, and FDE. Okay, so we begin by isolating joint B. So that's 900 newtons. We begin by computing for the reaction components. First, summation moment about BCX. So FAE is 0. Summation moment about axis BCX or along BX equals 0. Then by right thumb rule, so it is dy times 3 dy times 3 minus 900 times 3 equals 0. So that's the only forces because DC is passing through BCX. So dy is 900 newtons upward as shown. Then summation moment about By equals 0 to solve for dz. So by right thumb rule, so 900, so this is positive following the four fingers, curling of the four fingers. 900 times 0.6 minus dz times 1.8 equals 0. All the rest will be 0 because uh, they are parallel to the y-axis. So that dz is equal to 300 newtons in the assumed direction, which is forward towards the z-axis. Then summation of moment about fx or summation forces x equals 0 since considering the entire system, so bx plus nothing equals 0, so bx is 0. And summation of moment about cy, here cy equals 0 to solve for bz. So bz is positive, bz times 1.8, then minus 900 times 1.2 equals 0. So bz is equal to 600 newtons and the assumed direction for bz is correct. So we only have by left, so summation moment about cdz, dez rather, to solve for cy. So dy is already solved, it's positive, then minus cy times 1.8. dy times 1.8, so 900 times 1.8 minus cy times 1.8, positive in that sense, equals 0. So cy is equal to 900 newtons downward. And finally, summation moment about cdz equals 0. So we have negative by times 1.8 plus nothing equals 0 because everything will be 0. And 900 is parallel to the CDZ axis. So we conclude that by is 0. Then beginning with b, summation versus y equals 0. So FAB times vertical component 3, distance 3.15 plus nothing equals 0 because by is 0. So therefore AB is also 0. FAB is 0. Summation forces x equals 0 at B. So we have BX plus FBC equals 0. Because AB has no component about the x-axis, along the x-axis because FAB is 0. So therefore, FBC is also 0. So again, the equation is supposedly FBC plus BX, which is 0, equals 0. So FBC is 0. Then summation forces along Z at B equals 0. So we have BZ, we already computed BZ, 600, then minus FBE. So those are the only involved forces because remember FAB is 0, equals 0. So 600 minus FBE equals 0, so FBE is 600 newtons tension. Then we proceed to join C, summation forces y equals 0. So FAC times vertical component 3 divided by distance 3.317 minus cy, which is equal to 900, equals 0. So FAC times 3 over 3.317 minus 900 equals 0. So FAC is 995.1 newtons tension. Then we sum up forces along X equals 0 at C. So positive in the opposite direction. So remember FDC is 0. So we have FCE times 1.8 divided by distance of FCE is 3.499. Then plus FAC 995.1 times 1.2, the x-component of distance, 1.2 divided by distance of FAC 3.317 equals 0. So FCE is equal to negative 699.8 or 699.8 newtons compression. And summation forces along Z equals 0, positive in the negative direction of Z. So we have FCE, which is negative 699.8 times 3 divided by distance 3.499 plus FCD equals 0. So FCD plus negative 699.8 times 3 over 3.499 equals 0. So then plus component of FAC is 995.1, then Z component is 0.75, Z component of distance 0.75 divided by distance of FAC is 3.317 equals 0. So FCD is equal to positive 375 newtons, so it is tension. Now we proceed to joint D, summation forces Y first, equals 0. So upward, of course, the upward positive. So FAD times component of distance 3 divided by distance 3.937, then plus dy, which is 900, equals 0. So FAD is equal to negative 1,181.1 newtons, or 1,181.1 newtons. FAD is compression. Since we already found FCD, so the next equation is summation forces along x equals 0 and positive in the negative direction of x. So we have FDE plus FAD, which is negative 1181.1 times 1.2, x component of distance divided by distance of FAD 3.937 equals 0. So FDE is 360 newtons tension. So all forces have been found. Then let's check and verify these answers by considering joint A. So at A, summation forces X equals, we have FAC, it's FAD first, negative 1181.1 times 1.2, x component of distance divided by distance 3.937, then plus FAC, take note, FAB and FAE are zeros, so there are only two forces to be considered. So plus FAC 995.1 newtons times 1.2 divided by 3.317, the distance. Then if we evaluate that, that's 0. So okay, summation forces Y at A equals, so everything is going down, so negative FAD is negative, it is compression, so negative 1181.1 times 0.1 times Y component of distance 3 divided by distance 3.937 plus FAC 995.1 times 3 divided by 3.317, then evaluating, it is also 0. Then lastly, summation forces along Z equals FAD negative 111.1 times Z component of distance 2.25 over distance 3.937, then plus 995.1 times 0.75 over distance of AC 3.317, and minus 900, then evaluating, that's also 0. So that checks our all answers.